good afternoon, everyone, and welcome to our Southern Fire Exchange webinar today. My name is David Godwin, and I'm the director of the Southern Fire Exchange program with the University of Florida. Today, we're excited to feature a presentation by Dr. Holly Nowell. Holly is the Geospatial Program Director at Tall Timbers Research Station and Land Conservancy in Tallahassee, Florida. Holly will be sharing a presentation on the latest innovations and progress coming from the Southeast FireMap project. Dr. Nowell has a bachelor's degree in Earth and Planetary Science from Washington University in St. Louis, and she has 2 master's degrees from Florida State University in Meteorology and GIS, and a Ph.D. in Meteorology also from Florida State University. In 2022, Holly joined Tall Timbers as a project research scientist focused on answering various research questions tied to the Southeast FireMap. And earlier this year, she was promoted to director of the Tall Timbers Geospatial Lab. So congrats, Holly, and welcome. We're glad you're here. Thank you, everybody who's joined us online. And one moment as we trade out presentations.
All right, as David was saying, I am going to talk today about how we can use the Southeast FireMap project to track fire usage and trends across the Southeast United States. So first off, I want to start with a little bit of background with people that may not be familiar with fires in the Southeast United States and how we can use satellite to track them. So first is my map right here. This is from the Global Fire Emissions Database. This is another satellite-based product that I will not be doing a lot of talking about today, but this particular one is based off of NASA's MODIS sensor. And this shows mean fuel consumption in fires from 1997 to 2000 or 2020. So what you notice right away is this kind of bullseye area over the Southeast United States. There's a lot of burning that's going on here. And that's true. The Southeast United States contains half of all fire area in the contiguous United States on any given year, and the state of Florida alone burns 10% of that. So across such a broad region, satellites are really critical for quantifying the amount of fire and where fire is occurring across the area. And there's a couple of different ways that satellites can detect fires. The first one is through active fire detections. And so this is a particular example using the Landsat satellite. And these fires don't have to be particularly large, but they do have to be intense for the satellite to detect them. Probably this method that's most commonly used in this area is burn scar or burned area detections. So this happens after a fire has occurred. So this is another image from Landsat. This is part of the Landsat Burned Area Essential Climate Variable product. This is an older product, and it's been the newest product out is the Landsat Burned Area product. But this one illustrates really well. That top panel is what the Landsat satellite can actually see. And what's in the red square is a burned area. And the bottom is that Landsat BA-ECV algorithm. And so areas that are red have a high burn probability of being a burned layer and not something that happened due to vegetation change or some other landscape change. Areas that are in yellow are probably burned, a little less likely, and areas in green, the algorithm does not determine that it has been a burned area. So you can see that it is picking up kind of the patchiness of the burn in this example. So that being said, there are some satellite detection issues that happen specifically. It can happen anywhere all over the world, but specifically in this region, we have more prescribed fires, and I'm going to talk about this in a little bit more detail in the upcoming slides. But these tend to be smaller and they're less severe than wildfires, so they are a little bit more difficult to detect. And then anybody that lives in this region, you'll know we have a lot of weather, so we have a lot of clouds. And those clouds can block satellite views. And this becomes a problem when most satellites, except your geostationary satellites, but most of these satellites like Landsat and the MODIS sensor, they only come around every 14 to 16 days, Landsat 16 days. So if it keeps coming every 16 days and each time there's clouds, you can go several weeks or even months between cloud-free views. So if the cloud's blocking the burn scar, we're not going to be able to see it. And the same is true with a canopy. If you have a really dense canopy, the trees can block us being able to see what's going down on the ground, and we might only be able to detect fires that are occurring in areas where the canopy is not so dense or there's a break in the canopy. And also going along with clouds is that we have a warm, wet climate. We have a really long growing season here. So if there's successive satellite overpasses that aren't getting a cloud-free view, by the next time we get a cloud-free view, which might be a couple of months later, it's starting to grow things in the burn scar already. You already have grasses and other vegetation coming up. So that algorithm might not be able to detect the full size of the burn scar if it can detect it at all. So here's another example right here. Again, this is from the Landsat satellite data using the Landsat BA-ECB algorithm. And so the red squares are showing a burned area that was not detected by the algorithm, which is on that bottom panel. So these represent days. So 1988-203 is the 203rd day of the year in 1988. So every 16 or 17 days, it had a couple of overpasses where it's cloudy. And by the time it had a clear shot at it again, in days 267 and 283, it was too overgrown. It was too green. It didn't detect the burn area. Similarly to the yellow rectangle on that panel for day 235, it is detecting it, but you can see there's clouds in the way. So it doesn't get a really good look at it. It doesn't have a high burn probability. It's in that yellow color. And then just 17 days later, you can see how much it's overgrown. So it's already greened up and it's picking up even less of that burned area. So what that means is that the algorithm is not able to capture what it would have been right after the day after the burn because of these satellite overpasses and the clouds getting in the way and the green up. So with all that being said, how can we measure fire across the Southeast? Is this the best method to use? So there was actually a paper I did in 2018. This was back when I was a postdoc at Florida State, but I worked closely with people here at Tall Timbers. And we wanted to look at the state of fire across Florida. So Florida has ground-based records. We have the prescribed fire permits, or the open burn authorizations, as we call them here in Florida, from the Florida Forest Service, where if you burn a large prescribed burn, you are required to get a permit. So we were able to request those. We use the wildfire fire occurrence database created by Karen Short to get those wildfire reports. And what we found is that annually across the state of Florida, the study was for 2004 to 2015, there were about 25,000 fires that occurred in Florida, burned about 987,000 hectares, or 7% of Florida's total land area was burned every single year. And the vast majority of that was prescribed fire. Only 8% of it was wildfire. And so then that goes again back to the fact that we have those issues that I just talked about. So we have so many prescribed fires, but we still have the clouds, we still have the canopies, we have the rapid vegetation growth, and these prescribed fires only tend to be about 20 hectares, which is about 40 acres or less in size. So when we compare these ground-based records against what the satellite is seeing, here again, I show the Global Fire Emissions Database, we find that if you consider the ground records to be the truth, that over 70 to 80% of Florida fire area was missed by the common satellite products that were used as of 2018. But I should put a big caveat here, this is already 6 years ago. So satellite products have been updated a great deal since then. But this was consistent with some past literature and other studies comparing ground records and all of that. So then I think the next logical question would be, okay, well, then why do we just not use the ground records? Why do we use satellite at all? We can just go with those ground-based records. Well, if you tuned into the webinar a couple of weeks ago, or you can go back and watch the recording if you didn't catch it, Karen Cummins talked about the Southeast Prescribed Fire Database that she has created here at Tall Timbers. And she said, in her paper, it's very clear that not all ground-based products across the Southeast US are the same. So here's a table from her paper. There's inconsistent rules and variable time series between states. Some of the states in the Southeast, they do not require permits, they're voluntary. Others do require permits, but they might only be for a few months out of the year and not the entire year. Maybe they didn't start collecting data until 2014 or 2015. And then in the case of Georgia, they required permits, but up until 2015 or 2016, all fire permits that were granted within a county were geocoded to the county centroid. So we don't actually have a good spatial location of where those fires took place. Also, it is point-based data, the same with the fire occurrence database I mentioned about wildfires. So we don't have a spatial footprint of the fire. So here's another image from Karen's paper. And she was able to create a heat map weighted by area. So we get kind of these hotspots of where we know a lot of fire is occurring. But again, we don't know the orientation of the fire. We don't know the actual shape of it. And also, just because a permit has been requested and granted doesn't mean that a burn actually took place. So this can mean a couple of different things. It can mean they pulled a permit that day because you need to pull it the same day you burn. And then something happened and they ended up not burning that day. And then they go back a couple weeks later and they pull another permit. Most states do not track if a permit is reissued. Like if it was for a burn that didn't take place, they don't track if a burn actually took place, and they don't track how much of that burning happened. So, for example, if you were burning, you might know that your particular parcel that you're burning is 100 acres, but maybe only 60 of those acres are burnable. So that is not going to be reflected in the permit. So several organizations, along with the USDA's National Resource Conservation Service, uh, or the NRCS, they put out a call that there is really a critical need for a tool that can be used to track fire uniformly and accurately across the entire Southeast United States, because then this can help organizations and landowners know where to apply fire for restoration and conservation purposes. But they really emphasize the need for public and private land tracking. Because private lands are dominant across the Southeast United States. Only 17% is public lands, and all of these animals and the plants, the longleaf pine, for example, all of them are fire dependent species, and they just don't stop at, they don't care if it's private or public land, they just don't stop there. So they also live on private lands, and if we are interested in maintaining habitat for these species, we need to apply fire where they're located. So this is what led to the creation of Southeast FireMap. And Tall Timbers was involved from the beginning. And we first came up with a list of recommendations for a product. Like, what would a product that answered that data call look like? Well, first, at the very base, it has to be a database that depicts fire occurrences in the southeastern United States. But what can we base that on? Well, logically, we can look at the prescribed fire database that I just talked about. And one of the reasons I talked about that might be a negative for it, it doesn't allow viewing of spatial extent. And so we felt that that was really going to be something critical that was needed. View the actual shape of the fire and where that fire was actually occurring. Well, then we already have a similar product. We have Monitoring Trends and Burn Severity, or the MTBS. It has a spatial footprint. It also has a long record, which is another thing that was recommended. It goes back to 1994. But then the issue is that it doesn't quantify small fires. These are for fires that are only a few hundred acres in size and above. And most of the fires that are in the Southeast United States, those prescribed fires are, 20 hectares or 40 acres or so in size. So they're not going to be in the MTBS product. And finally, it was decided that it would be really great to have a web interface that was easy to disseminate this data. And also in the future, something that can generate simple queries and reports so that private citizens can use it. Scientists can use it if you just want some quick and dirty calculations or some numbers to put into a grant proposal. And we were then tasked with building this product. So they did an analysis across all the available satellite products and found that the Landsat burned area product, which is the new version of the Landsat BAE, or burned area essential climate variable product that I analyzed in the 2018 paper, had really made a lot of improvements and was the best at detecting fires in the Southeast United States. And as kind of an added bonus, the partners at USGS, Todd Hawbaker, Melanie Vanderhoof, and Josh Pacat, they were very interested in working with us on a region-specific model and adapting their algorithm to detect more fires more accurately in the Southeast United States. So we built the Southeast FireMap project off of the Landsat burned area product. And this is what's currently available. This is version 1. It's still in beta. And you can see that it is within the Southeast United States. It is currently in the historic longleaf pine extent. We have in more recent years updated it. So now it extends through the rest of Florida and South Louisiana. And we are looking to expand it into other states to kind of complete each state. And you will also notice that in addition to having a spatial footprint, it is color coded. So it is actually color coded with something that we call a fire history metric that we were able to develop for each burned area or each burned polygon. Because we have a spatial footprint, we can determine things such as fire frequency for each polygon. That's how many times a specific location or that burned area burned during our record. And this goes back to 1994. So currently it's 1994 to 2022, and we're working on the 2023 update right now. We could also look at something since like time since previous fire. How many years ago was fire last detected in this polygon? The year last burned, which is something similar. It just gives the year a fire was last detected, and the longest fire-free interval, which is in years. So how something like this could be helpful. So if you have this long time series, 1994 to 2022, and you're trying to look for, you're seeing if a polygon is being maintained by enough fire to maintain some of those fire dependent species I showed earlier. So you may look at a fire frequency, and if you have 10, you may think, oh, well, it's burned maybe every 3 years or so. So that would be a pretty good return interval. But then you look at something like longest fire-free interval and you see it's 15 years, and then it hasn't burned since 2007, according to your last burn, then you will know that's burned a lot at the beginning of this time period for this data set, and then it hasn't been touched by fire at all in 15 years. So it's no longer an appropriately maintained landscape, and we need to go investigate that further. Currently, we are in phase 2 of Southeast FireMap. We're just continuing product development, and there's a lot on this slide, and we're doing a lot of work on it. But what I'm going to be focused on for the bulk of my talk today is how we can use the Southeast FireMap product, how I'm using it to showcase the type of research and questions we can answer about fire and how it is being applied across the landscape. So first of all, I wanted to focus only on ecologically significant fires. So what does that mean? Well, I use the USGS Land Change Monitoring Assessment and Projection, or the LCMAP product, to determine what the primary land cover types would be for each burned area polygon. Because I'm interested in grass shrub burning that happens in tree covered and wetlands. But what I wasn't interested in and what I wanted to exclude was cropland burning and burning that is shown to be on barren water and developed lands. So for cropland burning, those are agricultural burns. So the reasons why agricultural burns are taking place are different than why burning's taking place on these other landscapes. So, and then with barren, water, and developed, these could mean a couple of different things. They might be low frequency fires that happened as a land clearing effort to make way for development. So those aren't ecologically significant. Those were done by the drivers for applying fire to that landscape are done by different means. And then barren and water could be a misattribution by the LCMAP product. And we did find in the research, I should mention this is an upcoming paper that I'm still working on. So did discover in this research when looking at ground validation data that LCMAP did have a tendency to misclassify, especially grass shrublands, which I consider ecologically significant burning. It would misattribute them as cropland. So I did some further research and found kind of a methodology that we can use to tease apart some areas that we believe are actually grassland shrub but are misclassified as cropland. And so to note that and keep that in the analysis, I created a new mixed use category. And so I put those into this mixed use category instead of just reattributing them as grass shrubs, so we can keep track of them. So then I thought it would be interesting to look at decadal burning trends. So instead of year-to-year trends, which can be variable, if we do summations over decades, that might be more informative. So I looked at what burning looked like from 2000 to 2009, that's on the left panel, and then from 2010 to 2019 on the right panel. And so from here on out, for the bulk of my analysis, I'm going to be assessing what I call unique burned area. So each thing that's colored orange here is a burned area polygon, and that has an area associated with it. Now, what's nice about Southeast FireMap, and we have these fire history metrics, we know frequency and we know what years it burned, so we can easily figure out what's total burned area for this time period by just multiplying the area by the frequency. But I'm not doing that here. I'm just interested in how much fire was applied to the landscape in unique land areas during the given decade. So if you stare at this map for a long time, which I've been guilty of doing, You might notice visually some trends that are happening, such as in the coastal Texas and Louisiana areas, you have decreased burning. It appears to have burned less area from 2010 to 2019. Similarly, in South Carolina, some burnings decreased. You have decreased burning in Okefenokee, and Northwest Alabama. They increased burning in the 2010s. And then you kind of had a shift in burning patterns in North Carolina. You had it a little bit more inland from the coast. And then in the 2000s and the 2010s, it was more along the coast. Well, we could spend a really long time looking at all this burn data, but I went ahead and summarized it over the entire region. And so over the entire Southeast FireMap extent from 2009 to from 2000 to 2009, it burned a little less than 4.3 million hectares. And then from 2010 to 2019, it burned a little bit more than 4.3 million hectares. So that, is interesting. But what if we teased it apart even more? Because it looks like it's slightly increased. But what was happening at different areas of the landscape? So for example, by ownership, because the call was really interested in looking what was happening on private versus public lands. Are they both experiencing the same thing uniformly when it comes to fire? So we took the USGS Public Access Database, or the PAD data set, to determine whether area was public or privately owned. And what we found is that the numbers varied a little bit. So we are dominated by private burning in the Southeast United States. There's less public burning over the region, and there appears to be a little bit less private burning going on between decades and a little bit more public burning going on. So what does that look like by state? Are we also seeing the same things by state? Can we apply that blanket statement everywhere? And for the most part, what we see is that most states do have more private land burning than public land burning, with the exception of Florida. Florida in the 2010s has more unique land area burned publicly than privately. And what's the decadal difference? So we have these numbers. Are they trending up and down? So with the Southeast United States, I'm going to put this in graphic form because that's a little bit easier to look at. So in total, we know that across the Southeast US, burned area actually increased. It has this, you can see on the table, a 1% increase. We burned about 41,000 more hectares in the 2010s than 2019s, but that's not what happened on public and private land. So here in this figure right here on the right, I showed the difference in unique burned area between the decades. So I took the total amount of unique area that was burned in the 2010s, and from that I subtracted the total amount of unique area that was burned in the 2000s. And so anything that's above the zero line indicates an increase in burning. So more land was burned in the 2010s. And everything below the zero line means that less land was burned in the 2010s. And the black dot represents if you sum all of that together. So in total, it increased by 41,000 hectares about, or a 1% increase. But what that is masking, if you just look at that number, you wouldn't know that public land burning increased. And that was countered somewhat by a decrease in private land burning. But overall, we did see decreased private land burning of unique areas. And if we take a look at that and we carry that across the states and look at the states, we don't exactly see the same pattern. So in about 3 of those states, we do see the same, where there's an increase in public land burning between the decades, but decreased private land burning. However, in the states of Alabama and Florida, that increase in public land burning was not enough to negate the fact that there was a large decrease in private land burning. So in total, between the 2 decades, Florida burned less unique land area, and so did Alabama, than they did in the 2000s. Virginia was actually about the same. So if you just, again, looked at the total number, you would think, oh, they're pretty steady in burning, but that's covering up a slight decrease in private land burning and a slight increase in public. Now you have North Carolina, which maintained private land burning. There wasn't a large change, but there was a large increase in public land burning. And then for Georgia and South Carolina, they increased in both public and private land. And Louisiana and Mississippi, they decreased burning in both land ownership types. So just to give a brief, overview of everything I just discussed with all these figures, if you just look at the high level. Just look at the Southeast United States. Overall, there was increased burning, but that's kind of masking the fact that there was a decrease on private land burning, and there was an increase in public land burning of unique areas. And at the state level, it's kind of a mixed bag. Actually, the majority of the states decreased burning. While there are large declines in private land burning for the majority of states, there were modest increases for most of the states with public land burning. And Georgia really had a large increase in everything. But you might be asking, well, cool, but how is this information useful? And I've had queries about this, and it actually has been used to direct grant applications. So for example, direct outreach and resources for private land burning to particular states. You can see some states have these large decreases, so maybe a private burn association is applying for grants to get more people on the ground to interact with more landowners in areas where they see decreases in private land burning. And it really kind of asks the question of, why is this burning taking place? So this can lead to more research questions. Now, I did that with ownership, but we can also do that to answer other questions by using things such as land cover. So if we use land cover as well, so here is just the LC map product that I was talking about earlier, we'd see that the typical pattern across this area is you have mostly in the Southeast United States, on average, there's more tree covered burning and followed 2 and 3 are really close together, grass, shrub, and wetland. And that mixed use category I created is kind of the fourth. But when you look at it by state, there's 4 states that follow that same pattern, have a lot of tree covered burning followed by grass, shrub, and wetlands. And that's Georgia, Mississippi, South Carolina, and Texas. But there's also several states that do the most burning in wetlands, or a large proportion of wetlands. And then if you look at that difference, the decadal difference between the decades, you can start seeing like what's happening and where we're losing fire in some of these ecologically important landscapes. So for example, here is that difference figure again. And so again, across the entire Southeast United States, there was increased burned area. And we can see when we're looking just at land cover, that was driven by an increase in burning that happened on tree covered lands. But wetland areas, grass, shrub, and mixed use declined in burning between decades. So less of those important ecosystems were burned in the 2010s compared to the 2000s. And so if we break that down by state level, we kind of see a mixed bag. Again, we have Alabama, Florida, and Louisiana. They all had increased tree covered burning. They all had decreased burning in the other 3 categories. So they kind of followed that trend with the Southeast United States, but they had large decreases in overall burning of unique areas. And in the case of Florida, it was primarily driven by less wetland burning in the 2010s than the 2000s. Mississippi and Texas, they decreased burning across all land cover types. Georgia, North Carolina, and South Carolina, they had majority increases in most land cover types. North Carolina and South Carolina, they had slight decreases in grass, shrub, and mixed use, but these were more than counteracted by the increases in tree-covered wetland or grass shrub, depending on the state. And so in summary, just going back over all of this again, so these decadal trends across land cover types, the Southeast United States, again, there's increased burning, but this comes with increases in tree covered landscapes, decreases in wetland and grass shrub and mixed use. And at the state level, we see a majority of states, again, have that decreased burning. They're burning less unique area than they did previously. And then most had an increase actually in tree covered land burning, but this was counteracted by decreases across the other land cover types. So there might be another example of, how is this useful? How can we use information about how burning trends are changing across different land cover types? And so I'm actually giving an example. Tall timbers, we have a land conservancy attached, and they're frequently support easements and looking for property to put under easements for environmental protection. And they actually use Southeast FireMap in their prioritization tool. So this helps rank what areas are best for conservation. So for example, right here, this is the tool that we have created for them and that they use actively in their office. So they have created a weighted overlay where they combine several different layers. They use some fire history metrics for Southeast FireMap, land cover, climate resiliency, proximity for other protected areas, and they have weighted all these according to their expert opinion, and it runs through a program, and then it creates uh, values across the landscape. High priority values, which were considered, something you want to put into easement versus lower priority values. So for example, here within this region right here, outlined in black, if they're looking for areas to put under easement, they're going to want to go for those areas that are red. So that indicates that it has what they deem to be good fire history metrics, land cover type that they want to maintain. It's close to other easements that we might already have. So it kind of create a connection corridor right there to help improve animal habitat. So that is one of the ways that we can use Southeast FireMap in a real world example. Now, if you're still hanging with me, one of the questions you might be asking is, okay, well, I discussed some of the pluses and minuses of satellite-based data set, and I showed a whole bunch of satellite-based data results, but we also have this component of those ground-based records, which also have pluses and minuses. So are the results going to drastically change if we use one data set versus another? And just make everything kind of confusing and maybe make some of these results moot. So I went ahead and took a look at that. So I took those ground-based data sets we have. Again, it's that Southeastern US prescribed fire permit database for permits all across the Southeast United States. It's the only one of its kind that has permits from all across the region. And then I took those wildfire reports again from the Fire Program Analysis Fire Occurrence database that Karen Short compiled. And I compared them to a total burned area from 2010 to 2019 from Southeast FireMap. So previously I was discussing unique burned area, but since the ground-based data sets are point-based, I can't tell if they overlap or not. So I'm not sure what's a uniquely burned area or how many times a particular area has been hit by fire because it's point-based. So this time I used total burned area, which again is the flexibility of Southeast FireMap. So I took the area of a polygon and I multiplied it by how many times it burned from 2010 to 2019. And this is only focusing on ecologically significant fires. So I did the same process with the ground-based data where I restricted, I tossed out cropland and then the water and urban and developed areas in barren. And so I compared them to each other. And so here are the results. So Southeast FireMap is on the left panel and the ground-based data sets are on the right panel. So what you may notice obviously right away is that Southeast FireMap is showing less burned area than reported by those ground-based data sets. So this could be due to missed satellite detections. I talked about how you have repeated satellite overpasses. You may not pick up fire. But also the ground-based data sets are not perfect. So it can be inaccurate permit data. This can be the spatial location was off by quite a bit. And because we don't have a spatial footprint, we just have a user entered lat long, or sometimes they do township, section, and range, which if you're familiar with that, you know how burdensome that can be. So we might have inexact locations. We might have the instances where, the burn didn't actually take place, maybe only half of the requested acreage burned, and there's no follow-up on that. But what we found really interesting was that the trends are similar. So it's still showing it's exact, showing 60% private land burning versus 40% public land burning. So the acreages are different, or sorry, in this case, the hectares are different, but the trend is similar. And what we noticed is when we took it down to the state level, and so here, the states that require permits, the trends are still similar. So sorry, the font's a little small on this slide, but so for Alabama, Florida, Mississippi, North Carolina, and South Carolina, we're getting the trends that are fairly close within a few percentage points of each other. So if we're doing it over a large enough land, we can see that, oh, it is dominated by public land burning, it's dominated by private land burning, and the trends are the same, whether they're based upon the ownership division. So we think where Southeast FireMap might be able to contribute more is especially has added value in the states where permitting is not required, or there's other permitting issues such as in the state of Georgia where for years they put everything until 2016 into the county centroid. So we don't have an accurate spatial location of that. So no matter whether it was public or private, wherever that county centroid is located, that's what that permit's going to get assigned to, whether or not it was actually burned there. So because we have such good correlations with the trends that are happening in areas where permits were required, we think that what's being viewed by Southeast FireMap as far as trends go is more accurate than just the permit data alone, especially in these states where permits are not required. And we don't know what's being reported and why and what's not being reported, but we can see that with Southeast FireMap. So for example, if we're just looking at the ground-based records in Louisiana, it looks like public burning is very dominant. But looking at Southeast FireMap, we see the trend we see across most regions and most states in the region, is it's mostly private land burning. So this can be very informative for areas where we do not have good permit records. So all of that being said, like I said, Southeast FireMap, we're in phase 2, and so we're working on improvements. And one of them is improved detections. And you saw the burned areas look different. And I discussed the issues we have with cloud cover and satellite overpasses and green up. So one of the things we are actually very actively working on, I just had a meeting before this where we were discussing this very topic, was we are working with the harmonized Landsat Sentinel-2 data product. So the Sentinel-2 is a series of 2 European satellites, and they have a revisit time of every couple of days. So instead of the Landsat satellite being the sole source of data, only going over an area every 16 days, every 2 or 3 days, we're having a Sentinel-2 data. Sentinel-2 satellite overpass. So we're able to collect data on those days. So what that does is that opens up the amount of cloud-free viewing days we can get. So here's an example. It's very small, but that red little rectangle in Florida represents a single tile. Landsat does their data based on tiles. So this is over kind of in northeast Florida, kind of in the Big Bend region. Just looking at the number of burns that were detected in a given year. So with all the cloud-free satellite images we had for this particular area, Landsat, for example, in 2018 said that there were only 69 burns that occurred. But with the inclusion of Sentinel-2 data and its more frequent overpass and revisit time, and just the sheer amount of fact that it can get more images that are cloud-free, it detected 426 burned areas. So depending on the year, Satellite-2 data, Sentinel-2 data, when it's included, increases observation counts between 43 to 300%. So we are currently working on including that. We're going to have 2 data sources. We're going to continue to have the historic Landsat only based product. So we have that history that goes back to 1994. And then we're going to have a product going forward that includes both Landsat and Sentinel-2 data from 2017 onward. And as I say, that's a work in progress right now that we're actively working on. We're also working on adding enhanced data and features to Southeast FireMap. One of them that our end users really want is burn severity. Can we measure how severe that particular burn was? And then we're also creating some decision support tools, such as if you want to jump on, really quickly run some data. What's the average burned area from 2009 to 2012 in 5 counties in Florida? That would be something that this product could do, but that's currently in development. And so just in conclusion, to wrap it all up, you just talked about how fires can be difficult to uniformly track in the Southeast United States. There's different data products available, and they each have their caveats to them. Using Southeast FireMap, we can measure fire trends over time because we have this long data set with a spatial footprint, and the trends do vary based on spatial extent. So it's not you calculate one number and it fits everything. You can get down by state, you can get down by county, and this information can be used to direct resources and conduct research. Again, there are some caveats to using this data. No detected fire does not mean the absence of fire. So just because we've had landowners and fire practitioners that came up to us and said, hey, I know I burned my land and it's not here. And that's probably up until the inclusion of the Sentinel-2 data, highly likely that we missed it because of clouds. There are instances where ransom numbers today, it can be 2 to 3 or maybe even 4 months before we have another cloud-free image where we can look at burn scars on the surface. So this is kind of more of an area of exploration. So not like, oh, well, I'm going to go, look at this land because they have a grant. They're supposed to burn every 2 years, but according to Southeast FireMap, they're only burning every 8 years. It's just, oh, okay, we're only recording a burn every 8 years. We should go check it out and see if this is what's actually happening. And then the trends that I talked about might not just be due to the cessation of fire, they could have changed land cover type. And so what was once classified as, a wetland burn became a tree covered burn. So that is something, but that's more for if you're looking at a specific area with knowledge, you can delve into that a little bit more. And as for the future of Southeast FireMap, I mentioned that we're improving satellite detections and including burn severity and decision support tools. So that is my current work with Southeast FireMap. Like I said, I'm working on a paper right now, in addition to some of the other results I showed here. And just wanted to thank the USDA NRCS, which is our funding agency, and the great partners we have at USGS, and of course the Longleaf Alliance, which really helped in the beginning stages of Southeast FireMap product. So now I can take some questions.
Well, Holly, thank you so much for your presentation. And everyone, if you joined us after we got started, my name is David Godwin, and I'm the director of the Southern Fire Exchange. And this was a presentation by Dr. Holly Nowell, who is she's the director of the Tall Timbers Geospatial program at Tall Timbers Research Station in Tallahassee, Florida. So at this point in our program, we have an opportunity to take questions from the audience. If you'll please use the Q&A tool in Zoom so that we can kind of sort and prioritize questions. If you see questions that other folks have already asked and you want us to try and get to it, there's a little thumbs up. Give it a click a thumbs up and we can kind of use that to prioritize. Thanks to the folks who've already put questions in during the presentation. Some really good ones already, Holly. I'm excited to try and get through these and see what you have to say. So in somewhat of an order, Glinda asked right way back at the beginning of your presentation if they could get a web address for the first map shown on your slide deck. So um,
The Global Fire Emissions Database, that one.
yeah, I'm not sure which one Glinda was referring to.
Yeah, you can, feel free to send me an email and I will direct you towards, I can give you that image or direct you towards the resource. Okay. Yeah, so that's the Global Fire Emissions Database. And that is actually a product that produced using a code called, or it's a global atmospheric circulation model called uh, I used a model to derive that. And so I can get that image to you if you're interested in that.
Great. And we'll at the end we'll put slides back up that has Holly's contact email on there so that you can get that there. We had a question from Lewis, and Lewis says, is there a plan for other regional conservancies to input data for tracking, or is it really just currently focused for the southeastern US?
Well, currently the Southeast FireMap project, we are focused on the Southeast US, but we are in talks eventually to expand it out to other regions. So it's not as easy as it looks. So we went in with the algorithm, played with the different thresholding and to make it more sensitive. And so other regions would need to be less sensitive or more sensitive. But one of the team members called, his name is Chris Matichek. He is soliciting burned area perimeters, like if you've actually gone back after a fire and mapped where it is anywhere across the Southeast region, to help us better make the model and find out where these errors are occurring. But yes, there are plans in the future to extend it out, grant permitting, grant funding.
Here's a question from Fred. Fred's asking if you've analyzed road density changes over time to see if that impacted prescribed burning on the landscape. He gives an
I
example from
I
timber harvesting in the Northeast.
Yes, I kind of have. I had to cut myself off because, like I said, I'm currently writing this paper and it was getting pretty long. But I did look at land fractionation. I was trying to look at that to see, that includes road networks. I was mainly looking at plot sizes or continuous sizes of similar landscapes to see if that has become more fractionated over time, to see if that correlates to these areas we're seeing burn decreases in. So a second paper that I am concurrently working on at the same time, we're focusing in on areas where we see hot spots of fire or where we see cold spots of fire, like where it was on using a lot of fire and dropped off, and then kind of diving more deeply into those regions to see why burning might have stopped. But that's not included in this analysis, but yes, it's on my to-do list.
And a good question here from A. McCulpin. Was there a difference in drought conditions in the 2 decades that might help explain the increases or decreases in burning,
That is
especially
something.
with different land cover types?
Yes, that is something that I looked at for that 2018 paper I did. It did include drought indices. It included uh, I also looked at whether or not El Nino patterns affected that, but mainly drought indices, both a long-term index and a short-term index. I did not include that in this particular paper that I'm working on. It's just more of an overall observed trend because that can be pretty localized. So that would be something like if you're interested in a particular region or particular county, then you can dive into those drought indices to see what is going on that local level. But that's not something I did over a regional one for this one.
It's a good point and a good question for sure.
Yeah.
Let's see. Lewis asked, has there been a determination if the decrease in private lands burning is related to federal lands programs, cost share programs such as CRP, or resulted in enrollment or completion of those program requirements?
That is something that we are going to put in paper too.
Oh, cool. That is
Yeah.
another good question, Lewis. Yeah, interesting to see if those programs are having an effect at different scale. And of course, there's state level cost share
Yes.
programs that are also
Yeah,
trying
like
to
I
do.
said, I with a lot of great ideas, but I had to eventually cut myself off just to get something out. But yeah, we're looking at that. If it's across, if there's particular issues going on with maybe a state forestry agency, if there was funding changes or something, that's all something that we're trying to look at for what we're referring to as the cultural fire landscape paper. And I'm working on that with Kevin Robertson, who's our fire ecologist, director of fire ecology here at Tall Timbers.
Todd also has an interesting question here that might try and bridge the gap between this and the permit data work. Todd asked, does any state require or request follow-up information about the permits? How did the burn actually occur, or how many acres were burned?
No state does that as a general rule. There have been studies where individual researchers have gone and done that and called individual landowners, but nothing is happening long term on a statewide level to follow up on those.
I know I've been in meetings where there were conversations about that, and there are definitely some strong opinions at
Yeah.
that very question. Uh, Lewis again asked the potential for duplicate reporting with Sentinel-2 and Landsat. Lewis is asking why not record only the Sentinel-2 data, which is a good point too.
Yes. Right now we are there's they're sussing it out. So, as my kids would say, um, they're not going to be double counting. So, if it's recorded by one, they're not going to assume that it's happening again. But the desire to keep both products is Sentinel data only started in 2017, and then it really came online in 2018. So if we just started with Sentinel, we lose all that great data that has already been collected by Landsat, because Landsat, we only go back to 1994 right now for Southeast FireMap, but the Landsat burned area product goes back to 1984. So we don't want to miss that historical record because then we couldn't do decadal studies like that. So that's why there's going to be multiple data products going forward. We're going to continue the Landsat only one. So it's a continuous, as much as continuous it can be, because new satellites go up and it improves detection, and that's just something we can't help. And but we're also going to have a combined data set. You can use Landsat history and then Landsat and Sentinel together, and then a Landsat and Sentinel only product.
We had a question from Mariah. What is the minimum area in acres for which this tool would be accurate or useful? For example, would the Southeast Fire Map show a prescribed fire footprint on a smaller than 10-acre or burn unit?
That's a
Good
good
question.
question that I did not bring up. So currently with Southeast FireMap, each Landsat detection is 30 meters, or a pixel is 30 meters by 30 meters. And to weed out noise and to get rid of that, a threshold has been set where you have to have 10 connecting pixels. So it has to be that minimum size of about 900 meters squared. So it's not in acres, but yeah, it's 900 meters squared is the minimum size. So that's about 2.2 acres. So it could theoretically detect a 10-acre, but we're trying to get rid of all the false positives you get and the noise you get when you get smaller than that.
Mhm. Donald asked if the decadal study included wildfire or only prescribed fires.
Yes, it's all fires. Currently, that's something I could have also mentioned as well. Currently, Southeast Fire Map, we don't differentiate between wild and prescribed. It is very difficult. It's just not as easy as overlaying the permits. There's that paper in 2018, there can be that I did, can be up to a 1 kilometer or more difference between the requested location and the location that the burns actually took place. That's for multiple reasons. We are working on an algorithm that might be able to discern what is a prescribed burn versus a wildfire. So that is, again, we're in phase 2. We're actively working on things. So that's an attribute we hope to add in the future.
Did you look at whether or not federal wildfire records have trends over the same periods of time? Could the federal wildfire records basically that show area burned by wildfire, with whatever caveats that comes with, does did you look at that as a potential way to explain some of the trends that you saw
I
from
have not,
multiple
but that's a
years?
great idea.
It would be interesting because, of course, the Southeast, and we have big wildfire years and other years where it's not
Yes.
so much. And that it looked like the margins between some of these um, increases and decreases were pretty small
Mhm.
by most of the time, except for a few cases,
Yeah,
except a few states at least. It would be interesting to see if wildfires, if that could explain some of that variability.
for sure.
Good question, Donald, for sure. Joe asked if you could go back to a slide which has the state by state FM fire map and ground-based data, so the permit map, I guess. Joe says, "What's happening in North Carolina?"
Okay, North Carolina, let me see. Go back to that. This, what was it? The state breakdown by, was it land cover type or ownership
It
type?
says by public and private, so I don't
Okay,
think that was the land cover one. Yeah.
okay. So, oh, with North Carolina having, let me pull it up. Sorry, I'm going through my slide deck. So yes, North Carolina, let me, so I can show the differences. So here, looking at the differences in North Carolina. So I can go back and look at just where I'm looking decadally what's going on. So North Carolina really registers no change at all in private land burning. It maintained the same level, so it burned the same amount of area, at least according to Southeast FireMap. So if we go, I go back. So if go back and look at North Carolina right here, yeah, you could see that there was a large increase in public area burning, of public unique area burning. and that private pretty much stayed the same. So that's why that was just increased because private stayed at a consistent level.
All right, wait. Joe, if you had more questions, then again, we'll have the email address up on the screen in just a minute for Holly. Um, Question from Mark. Good question here. Are there differences in the detectability of fires in different land cover types? So do you have different? Is it confidence the same essentially in the ability of the algorithm to detect fires in woodlands or wetlands or grasslands or?
No. We are working on that, but there is a tendency. It's really difficult we've done a lot of work. Melanie Vanderhoof from USGS, one of our partners that works on this, she has done a lot of work specifically with wetland burning. It is very difficult because to a satellite and the algorithms, wetland burning can look a lot like flooded areas. So it can be really hard to tell the difference. So she has done a lot of work trying to suss out whether or not it is burning versus just being a wetland, or if the water mask is discounting actual burning that's occurring. So that is probably the most problematic areas. Tree covered, as I said, if it's a really dense canopy, we're going to miss fire area there. If the satellite can't see through that canopy, it's not going to be able to see the ground, and it's not going to be able to see that full extent of the fire area. Probably the easiest is grass shrub because it's more open. And so that's just going to be easier for the burn scar detection.
Question here from Blake. Blake says he uses the Southeast FireMap on a regular basis, and it's an excellent resource. So good deal. Blake asked, do you happen to know when the 2023 fire history data will be available?
Well, good news for Blake. He probably talks a lot with Chris Matichek. It just got an update from him today that he has finished the data generation for the polygon layer, and that has been uploaded to the drive. And so the next step is to push it out to the Southeast FireMap portal. And so that should be coming in the next few days. It should be soon, barring any data transfer issues.
All right, good news, Blake. Good question. And then last, Gordon, I'm going to try and see if we can work our way through this one. Gordon says, I was required to report my burn accomplishments to AQMD. Does the Southeast Fire Map have air quality issues that would be required of that sort of thing? So, what do you think? I'm thinking asking questions about emissions data perhaps related to the burns.
Well, emissions data, that is something that I would like to, because I do have a history in smoke modeling. So emissions data is something I would like to add in the future. It wouldn't be something like plume modeling or anything like that, but just kind of giving a ballpark emissions estimate, basically roughly based on this land cover type with this emission factor and this burned area, it's going to produce, between X and X micrograms per meter cubed of, PM 2.5, ozone, NOx, what just the big heavy hitters when it comes to air pollution. But at current time, we don't have that. But that's something we're looking for a future release.
Yeah, certainly a very relevant question and topic with changes to the PM 2.5 National Ambient Air Quality Standards that rolled out earlier this year, and a lot of focus and interest in emissions and understanding prescribed fire smoke in the Southeast right now and going forward. Well, at this point, it looks like we have run up to a little bit over the end of our time today. So thank you everybody who joined us. Great questions. Thank you for your presentation, Holly. Holly, do you have any final comments or remarks that you'd like to share with us today?
Just really want the takeaway to be that it is difficult measuring what's going on across an entire landscape fire-wise. And there are, like I showed, there are pluses and minuses to each of the data sets we used, satellite versus ground-based. So it's really dependent upon you and like the research question you want to ask or the type of research you're doing, which data set would work best. But we're really trying hard, especially with Southeast FireMap, to increase the accuracy and just make it the go-to to use for this region.
Excellent. Well, thank you again for joining us, Holly. Enjoyed your presentation. Thanks everybody for the questions, really thoughtful questions today. If you would like to follow up with Holly, her contact information is on the screen right now. So, with that and everything, thank you everybody for joining us today. Great turnout, and thank you especially, Holly, for your presentation today.
Thank you.
Yep. Good afternoon, everybody. Take care.
Bye.